course, we're honored to have Gavin Wood speaking with us. Nate will do I know, a lovely introduction, no pressure there. And we'll do a fireside chat format. I have a couple of charts that I'm going to share. We're going to talk about the industry a little bit, and then we're going to be delving a little bit into Gavin's background. One of the goals for this Newton series, which is a change maker course, is for the students to really see themselves in you. And so we spend maybe a little bit more time on your background and what led you to make certain decisions than we do on the future of the industry, but we'll leave enough time on the future of the industry. I think we'll be talking for about 40 minutes, 45 minutes. And then we'll leave about 20 minutes at the end for students to ask questions. So it's fun for us to have this format. So thank you everyone for being with us. Good morning, Amrita. I don't know if you can turn on your camera or not. It'd be nice to see everybody. And with that, as I said, Nate jumped at the chance to introduce you. I didn't realize it's also because he's got this fascination with blockchain at Berkeley. He's the social and outreach director. He himself is pretty interesting. He's focused on econ, EECS, which is electrical engineering and computer sciences, and Chinese. I think that's an incredible combination. And he went to a high school, which is also one of my favorite things to actually say, Lick Wilmerding, which is actually a private school here in San Francisco. Nate, take it away.
Hey, thanks, Victoria. Well, I'm Nate, a sophomore, and I'm absolutely thrilled to introduce Dr. Gavin Wood today. So Dr. Wood received his master's and doctorate degrees from the University of York, where he studied music visualization for human-computer interfacing. And in 2013, Dr. Wood developed and became the co-founder and CTO of Ethereum, which is an open source blockchain-based decentralized software platform, which is typically used to deploy smart contracts and distributed applications. 2 years later, Dr. Wood founded Parity Technologies, a protocol that allows for seamless interoperability between blockchains. And at Parity, Dr. Wood has worked extensively on the development of Polkadot, which provides a highly scalable solution to create a network of blockchains. A few years ago, Dr. Wood founded the Web3 Foundation, which supports teams that contribute to building the decentralized web. So over the past few years, I've gotten to explore the blockchain space through Blockchain at Berkeley, Skydeck, and the Berkeley Blockchain Accelerator. And I've been lucky enough to benefit from and work with Solidity, Ethereum Virtual Machine, and so many more of Dr. Wood's contributions to the blockchain space. So without further ado, I'm happy to present Dr. Gavin Wood.
Hi, Gavin. I'm going to go ahead and share my screen and introduce myself for a moment also. Just in case. Hopefully there's a lovely picture of yourself and then me on the side. My name is Victoria Howell. It's an honor to be able to have this conversation with you. Just to set the stage, I believe you're, I hope it's okay to say where you are right now and what time it is.
Of course, yes.
And you are in Malta at the moment, and it's early afternoon as the lovely sun sets over the Mediterranean.
Precisely.
And talking to you from the Pacific, looking for the sun all day as it sets on us in about, I guess, 9 or 10 hours. So thanks for being with us. I thought it might be helpful. The Newton series has just a real diversity of students in it. And I thought it might be helpful to set the stage a little bit and talk about why it's really, really important to speak with you and to understand a little bit more about the cryptocurrency market. I found this chart on the internet. I don't know if you've seen it. I kind of butchered it a little bit, but I just wanted people to see that if you look at all the money in the world, this is from 2019, it's at about 83 trillion. And what's stunning is how much Bitcoin and now Ethereum and also DOT in terms of cryptocurrencies, how much they represent of money in the world. Wondering if you could kind of tell us a little bit about your perspective on the market and what got you into it? What made you think it was so interesting, worth your time? Because you could have done a lot of different things.
Yeah, well, thank you for the lovely introduction. And yes, it's nice to be here and have your attention. Honestly, I didn't like, I kind of when I first heard of Bitcoin, like back about 10 years ago, it seemed kind of dumb. It's like, oh, we're gonna have this like currency, and no one's gonna use it. It's like, okay, well, that's great for you guys, but I'm not really interested in exploring a currency that no one wants to use. So I ignored it. I kind of figured it was probably a sensible thing to buy, but then it was so difficult to buy any of it. Like back then, you had to like sign up through some offshore exchange. Oh, too much effort. But I came back to it in 2013 because it demonstrated that it actually had some sort of utility. It was being used online. It was being used on the Silk Road site, and it was through this that I kind of realized that you've got like this ability to have a permissionless, let's say, massively multi-user application, which is basically like, you know, a kind of currency application, a very simple application, you know, something that you might write when you're like, you know, doing some sort of early stage IT project, maybe when you're like 14 or something. But the fact that it couldn't be shut down, the fact that it was this kind of politically distributed and decentralized system was very interesting. It sort of showed that maybe far from organizations ruling software was now going to provide the rules for organizations. And this flip was something that really got my attention, much more so than any of the markets stuff. Although, you know, it's obviously quite fun to watch the little graph go up and down, up more fun than down, obviously. But
it all depends on your timing, by the way. But yes.
But no, the underlying proposition was much more interesting. And when Ethereum came along, you know, Vitalik had put forward this proposal. I was not quite a loose end, but I had a bit of spare time, so I offered to. I read it. I figured it was interesting, and it was also an interesting way of like learning more about the underlying nature of blockchain and crypto. So I figured it would be quite a nice little project to sort of help with.
So you mentioned that you mentioned something about what a 14-year-old might do as an early stage IT. Just curious, did you start doing things when you were 14 in IT technology?
No, that was back when I was about 8.
Okay.
So yeah, I got like a guy across the road had an old computer, very old computer. It's a TI, Texas Instruments TI 994A. So it's a very basic 8-bit machine. And he was throwing it out. My mum bought it off him for, you know, like $20 and gave it to me as a Christmas present. And I kind of started, you know, I had 3 games, and we didn't have a lot of money in my family, so we couldn't really afford like these games, like 40 or 50 pounds each. So you know, the only option I had for entertainment on it was to start writing my own stuff. So I started learning. I couldn't even afford the manual for the programming language, so I had to just had this like basic kind of programming language on it. So I had to just through trial and error, you know.
I mean, yeah, you would have to have a physical manual. I don't even think you would have gotten it online. So that's interesting.
In 1988, no, there was no there was no online back then.
That's so interesting. And so it seems like you had such an innate curiosity at 8. I mean, you know, some of us were playing on the playground. So that's kind of interesting to hear about that. And so getting back to cryptocurrency again, and what happened, you know, you kind of weren't interested in it at the beginning because nothing was happening. And then 2013, it became more interesting. And you said it was fascinating because it was successful, but decentralized. Could you just talk about that decentralization? Because you have all these names in the market, you know, you have Ethereum, and we'll talk about that more later. You have, you know, Bitcoin and Ripple. but I'm not sure what they do versus what the currency does. If I don't know if that question makes sense to you, but I think it's
yeah. I mean, so the thing is, you got something like Ripple, and Ripple's a currency. All right, it's listed on Coin Market Cap, but it would be best described as a digital currency, as a sort of internet, a currency that you can transact over the internet with, but in a digital country. But it's not decentralized and it's not permissionless. These are the key terms here. This is what's actually new. You can have a digital currency, and indeed there were digital currencies that predate Bitcoin substantially. But these were currencies that ultimately operated under a jurisdiction. Like there was a specific company that was behind them. They controlled who was allowed to own the currency, whether a transfer or transaction was allowed to happen, whether they could freeze someone's account, and all the rest of it. So these were little better than banks in many respects. And Ripple, broadly speaking, fits into this category. It's a digital currency, but it's not actually decentralized. At the end of the day, Ripple Incorporated can choose whether to federate out an additional issuer or not.
Got it.
Now, there's a few caveats to this, and they would argue, well, we're a little bit better than that, but basically that's the case. Now, with Bitcoin, which was the first truly decentralized, and when I say decentralized, again, there's a few different interpretations of this term going around. But with cryptocurrency, the key thing is that it's politically decentralized. That the decision-making power of the underlying software isn't controlled by any one particular power base. It's not the developers, it's not the miners, it's not the transactors, it's not the full nodes. It's like kind of a weird combination of all of them. It's very cloudy, very murky, and the only real consensus on what the decisions that should be made are is those that are already within the software, all those that were already made by the original, Satoshi Nakamoto, person who made the software. And that's the fact that it's only the software that allows for the software for it's only the software that determines what the network will do, and it's only the software that determines what a transaction means. This is a dramatic difference to what was the case all the way up until Bitcoin, with basically any software that you could or any service, I should say, that you could name to me, because services up until Bitcoin have all been based around an individual or a company offering those services to the rest of the world, to other businesses, B2B, consumers, whatever. But it's always a business that is offering the service. And in the case of Bitcoin, there was no business offering the service. The service was simply the emergent effect of all of these individuals running some particular software on their machine. And that emergent effect is a very interesting one. It's one that really differentiates Bitcoin from everything else. Now, the cryptocurrency part of it, the fact that there is a currency and there are market capitalizations and it's a coin, this is kind of, I wouldn't say it's not important, but it's almost like it's an implementation issue. It's like, well, how do we make it? Well, okay, it's two things. One of them, it's an application of the underlying software, so it provides a currency. Now, currency is a cool thing to provide. It means that I can send a number of units to someone else, and by send I mean that my balance gets reduced and their balance gets increased by the same amount. So there's this preservation of number of units, and that's basically the key attribute of a currency. Now, it would obviously be handy if these units retained value into the future and all the rest of it, but basically it had the key foundations of a currency. So that's the application, fine. But then there's also this notion of security, and the currency, the fact that people, or some people at least, attribute a value to units of this currency, means that if Bitcoin pays or rewards certain behavior through giving units of this currency to individuals, then it can incentivize behavior in the real world, right?
Yes.
So the fact that you can take this piece of software, just software, there's no company behind it, there's no operator behind it, this pure piece of software, and incentivize behavior in the real world, by which I mean have people run mining operations, have people do crazy amounts of research into creating ASICs, specialized computer chips that can run the SHA-256 algorithm extremely fast. This is a new thing. Normally software, when I release a piece of open source software, it doesn't incentivize anyone to do anything in and of itself. Like usually they already wanted to do something and they use my software to help them do it better. But in this case, it was the other way around. Through the creation of software, particular real world events were incentivized. And that is crazy. That's like this crazy flipping.
Did you have a hypothesis that it would happen that way, or did you just watch that unfold?
When I first heard of Bitcoin, I didn't see this. I was blinded by the apparent uselessness of the service that it presumably offered. And I didn't see that this was actually a way of allowing software to incentivize behavior where previously there was no economic weight, where previously there was no service provider behind it, no company behind it, no money behind it. Mm-hmm. I didn't see that. And all I saw was this kind of, hey, it's a currency that no one uses. Why don't you start using it? I didn't understand that motivation. But in reality, the fact that someone somewhere was willing to pay something for these units of account, these Bitcoins, actually meant that what we had was a system of software making incentives in the real world, incentivizing real world behavior. And that was critical.
So I'm going to just jump ahead on something. I'm curious, as you were thinking about that, when did you intersect? I'm thinking of like a Venn diagram, I guess. When did you intersect with the Canadians, for lack of a better word, the Ethereum? I think they're like 5 co-founders of Ethereum, and maybe you can correct me how that happened, how that meetup happened.
Sure. Let's see. It begins when I was reading a news article. I think it was in the Guardian newspaper.
Okay.
And this was in, I think, February or March 2013. Mm-hmm. And the article was about Bitcoin and how there's a guy who is a Bitcoin core developer. His name was Mihai. And how he and a bunch of his, crazy crypto cypherpunk guys are trying to change the world. And it was really cool. Like the article was good because it owed a lot to the fact that Mihai had recently moved into a squat. And the squat was like the most amazing squat you'd ever seen. It was a huge
what is
block.
a squat? Is that a UK term? Is that like, I'm in San Francisco, so you can imagine a squat is the thing under the bridge.
Yeah, so it's the thing under the bridge, but a building, right? So it's basically a disused building where people who otherwise don't have anywhere else to go are sleeping. Yeah. Now, Mihai is a very let's say kind of he's a guy who lives by his principles, and he does tend to stay in squats. And he was staying in this one particular squat in London, a very as far as squats go, it's a very large squat. It was a large office block, 5-6 floors, and it was in central London. Crazy. Anyway, I went to visit him at this squat because from the article, like the reporter went there, and it was like, this is crazy. You can see the city of London where all the banks are from this window, and here's like this guy who hadn't washed his clothes in several months at least. Who was, with a backdrop in this squat with a backdrop of the city of London. And it made a really kind of romantic story. I mean, romantics had a 17th century definition of romance, this kind of very passionate sort of story of someone who is taking on the banking world from their squat. Very very provoking.
It is pretty provoking.
I went there. I used to do a lot. I used to do some open source coding. I used to code for the KDE project. It's like one of the desktop environments on Linux. And I still had an email address from there, and I wanted to get his attention because I figured, you know, if he's big enough to be known from a newspaper article, then it's probably not going to be replying to cold call emails. So I emailed him from this KDE address, and sure enough, he replied, and he said, "Yeah, come to the squat and we can have a chat." So I went down to London. I was living up north in England at the time. And said,
was it like come into the squat and have a chat, or did he call you? I'm just curious.
No, he just replied. He's not a guy. I don't think he even has a phone. But if he does, it's, you know, he doesn't really use it to talk. So I went down to London, got the train down, and I said, I sort of met up with him in this squat. I was like, wow, I'm starstruck. I'm in a squat that was in an article in a newspaper. And he introduced me to a few people who were like a couple people that were in bed, and they were like, "Oh yeah, hi, okay, whatever." And he introduced me to a couple other people, and we started talking about Bitcoin. Now, the people he introduced me to, two of them, Johnny Bitcoin, as he was called, and Barry Bitcoin, as he was called. Now, Johnny Bitcoin and I stayed in touch with all of them, but Johnny Bitcoin in particular, now we met up every month or so to have a beer together. And eventually he introduced me to one of the Canadians, Vitalik. And he said, look, this is back in November, December 2013. Vitalik's just emailed me this like white paper of this like kind of Ethereum thing. It sounds kind of interesting. I'll forward it to you. So he forwarded me this white paper, and you know, yeah, it looked kind of interesting. Looked pretty badly defined. Like there was a lot of ambiguity in there, but it had the basis.
You know, a white paper. You have your PhD. You've written white papers, so it's interesting. And I think Vitalik, I don't know that he graduated officially from high school, so it's interesting to me.
Yeah, I think he went to university for like a few months, and then he quit.
Yeah.
But yeah, so he passed me on this white paper, and I kind of looked at it, and he introduced me to Vitalik, and I said, yeah, sure, I'll give you a hand coding it. So I kicked off. I started coding it maybe, I don't know, 18th, 19th, 20th December 2013, and I moved fast. I'm a fairly fast coder, and by mid-January, I had something that was kind of almost working. And I was like, you know, look, let's meet. Well, he actually came to me. He said, look, do you want to come to Miami and you can do a hackathon, and we can like finish it up? And I was like, yeah, sure. Miami sounds fun. It was pretty cold and rubbish in London back in January, you know. So I said, yeah, I mean, I didn't have any money at the time. I'd finished, I basically had run down my money doing a previous project, and was about to start like going to work at a bank or something. So I was like, you know, but would you get me a plane ticket? It was like, yeah, sure, no problem. We can have someone figure that out. So I took this plane over to Miami, and I met up with the other hackers, right? And the other hackers turned out to be nobody. It was just me.
It's all in the marketing.
Yeah, there was a few other Canadians that ended up becoming Ethereum founders, but yeah, it was really just me coding. But I basically that week in Miami, I finished it up, and I had something running by the end of it. Was
it called Ethereum at that point, or Ether?
The name was Ethereum. I mean, that was on the original white paper back. I think that was set to, you know, November. And I think the units were called Ether, but we didn't decide what the 3-letter currency code was going to be. That was decided a bit later in January, and it was between.
I have some, but I don't know what the 3-letter code is. What is that?
Oh, well, it's ETH. But at the time, it was between ETH and ETR. And I didn't like ETI. I wanted ETH. I want it to be pronounceable just as reading the three letters.
That
And
wasn't
ETR is like ETA.
That you wanted to say H? No.
Well, you know, that also.
No.
But no, I like the. I thought ETH sounded nice, and even now I don't really say Ether. I just say ETH. So yeah, that was when I met them. Anthony Diorio was there. He's one of the Canadians. Joe Lubin was there, also Canadian. I think Charles Hoskinson is American. I think he's from like Colorado or Utah or somewhere around there. And then Mihai was one of the founders. He was still in Romania, but it turned out that I'd actually been randomly introduced to Mihai. He was one of the guys in the bed in the squat back in London.
Yes.
Just randomly, and it's like, hello, person in bed, and it was like, oh yeah, hi, random person.
Yeah.
But yeah, we had been introduced. So actually,
I guess I want to clarify, they're in bed because they're pulling all-nighters.
No, they were in bed because they were just sleeping. Like Mihai wasn't coder.
Okay.
He's not a coder. He just made the Bitcoin magazine, and he was just sleeping with his girlfriend at the time.
Okay.
So yeah,
much more interesting than I thought. Okay.
Yeah. So Mihai, and then Jeff wasn't there. Jeff's one of the other founders. He's the other coder, but he didn't make it to Miami. As it turned out, I was the first person to actually meet in the flesh each of the other founders.
Interesting. And so I don't know if for anybody else, Gavin is frozen for a moment. Yes, so we'll wait just a minute.
But yeah, in total, there were eight of them.
So how do you start a company with 8 people, one of whom you met in bed, rumpled in bed? How does that work? And by the way, I know this is a gross generalization. Unlike Nate, who's like social director, I just can't imagine that all of you were super social and outgoing. Maybe you were.
No, we were not all super social and outgoing. But I would emphasize that there were only really 2 or 3 of the 8 founders that actually could code. Okay. So the other 5, Charles certainly knows his crypto and his maths, but not really someone you'd describe as like an avid coder. And then the other 4, I think maybe Joe Lubin used to code like 20 years ago or something. But they basically, none of them were really technical. And so they were reasonably socially adept. They provided, let's say, the more talkative and socially interactive parts of the crew.
And thus you became the CTO because you were one of the few that actually coded.
Yeah, and for that matter, I had quite a bit of experience, engineering things. I was, dare I say it, a professional. I had professional jobs.
With that, I'm just going to quickly flash up. We do often in the Newton series this timeline, just so people can kind of see, hopefully I can do this, can kind of see a little bit of your journey. I have some thoughts on it. I don't want to spend too much time on it because I've got so many fascinating questions for you, also from students. But if you look at it, of course, I think you were raised in, I think it's Lancaster, but you went to the University of York. You have your PhD. You worked on music visualization for human computer interface. And then I know this sounds weird, but when I look at this, I'm like, look, it's all very black and white until you pop into color with Ethereum. Hux Legal, I guess, was read. But you had quite a bit, 14 years of industry experience, at least.
Mm-hmm. Yeah,
so,
that's right.
Along the way, I'm wondering, are there certain experiences that were kind of foundational for what you brought to this team when in 2013, 2014?
Yeah, I'd say I'd say so. I mean, the team didn't really have any engineering background. Vitalik was, a very bright kid, obviously, and he, especially in terms of multidiscipline, like he had a good background in economics as well as computer science and maths. But no one had actually really engineered a system from the ground up. No one had certainly delivered a product from the ground up. Yeah. And so these are like pretty important things to do. Like you can have a great idea and you can prototype it and show that it works, but turning it into something that other people can use and moreover want to use is quite a different set of skills. And crucially, those two bits have to be able to talk. There needs to be some overlap so you can have a shared language and you can understand how the prototype needs to be turned into the product. And so that was really, I worked very closely with Vitalik. And whereas my underlying, maths and crypto was not a match to his, my sort of engineering ability and coding ability was perhaps a little, certainly architectural ability was perhaps a little beyond. And so we worked quite well as a team. We had a good ability to understand each other. And I would say, Jeff's also a very good coder in his own right. And Jeff and Vitalik didn't really have, Jeff, because he didn't have the academic background, he went basically directly from high school into coding. Yeah. I was able to really bridge between Vitalik's like very kind of theoretical machinations to Jeff's like, but what do I code that he needed to know. So when I tended to be the conduit that those two used to communicate.
We use this kind of archaic way sometimes when we're talking about entrepreneurship. You need the gas, you need the brake, and then you need the clutch. You sound like you were definitely a clutch. Doesn't sound like a good thing, but it actually is an incredibly important thing. What unlike when you're doing a startup, it's not like you're looking for VC money. You don't need a company to invest in you. You need people to believe in this and all these individuals, decentralized individuals, to invest. How did that happen? And then how did it scale so fast?
Bitcoin had just reached a pretty substantial high. I think it got to 1,000 or so, late 2013. People were feeling pretty rich.
And now, by the way, it's at
50 or 40 or something.
Yeah. Now, by the way.
Yeah. So people were feeling rich. It was basically just after the top of a bubble. So people were very, I went to this Miami Bitcoin conference in like early January 2014. And it was crazy, right? It was full on like Hollywood film, like ice sculptures and gold painted dancers and also like rooftop parties on the beach. It was full on. And I didn't answer anything like this. So this was like well beyond my experience. So I was pretty taken aback. And people wanted to invest. People wanted to take their Bitcoin and spend it and put it into the next Bitcoin. So it wasn't difficult to find people that had Bitcoin who wanted to like move it into the next big thing. And Ethereum was, it had a bit of star power with Vitalik having come from the Bitcoin world. It had Mihai, who ran the Bitcoin magazine. We had technology. We showed that we had stuff that worked. So it really wasn't difficult to try, to convince people to sort of buy into it. Now we raised about 50 million. And at the time, it seemed like a huge amount of cash, right? Huge. It was the second ICO that had ever been done. after Mastercoin had been done a few months before, and they raised, I think, around 1 million. So it was really big for the time. Of course, now it feels like not very much in the world of crypto.
Still big, but yeah.
But yeah, it really wasn't difficult to raise that much. We didn't really do any advertising. We didn't like try and in fact, we went, the funny thing is, we went around Silicon Valley, right? We went around Silicon Valley in March 2014, and we said, look, we have software, it works, it's like Bitcoin, but you can script it, you can like program it, you can make it do all sorts of random stuff. Do you want to, we weren't asking for their money exactly, but we were informing them that, this is what we were doing, and maybe they might want to buy into the sale. And no interest. Like, it was tumbleweed zone,
Did you get meetings? The Silicon Valley itself on like helping everybody, being open, anything?
Yeah, we got meetings. We met with, like, I don't know, at least 2 or 3 fairly big VC firms out there, and a few angels. But yeah, they were like, yeah, thanks for coming in. What you're doing is really interesting, but we're not going to put any money in.
Do you think they didn't understand it?
I don't know. I mean, either we're really bad at explaining, or somehow they weren't in a position to be able to grasp what it was that we were doing. And I suspect it's the latter.
So it's interesting because, in a weird way, ironically, I think it makes it more trustworthy. There's something about that is like, oh, well, there's something about trust there. And you talked a little bit about star power. I feel funny using that word, but there is star power. I mean, like I said, I drank from the fire hose this week, and this is the most like little soap opera, exciting area. And I am wondering, I mean, you have star power. How does that feel to have so much influence, or to have like Elon Musk go, well, maybe you should start to invest in this? I mean, what do you think of the role of that in this industry?
I think, broadly speaking, well, it is what it is. I think it's unfortunately quite corrupting, to be honest. The ecosystem, I would say, listens a bit too much to those that can gain the attention, and a bit too little to those who are saying sensible things. Unfortunately, those with the star power don't always, rarely, in my experience, say that, sensible stuff, say stuff that's worth actually taking notice of. And I think, I think this is an artifact of ecosystems, of social systems that grow. When they're small, the ones that don't have sensible people being listened to just die out really quickly, because if there's idiots that everyone's listening to, then nothing works. So for it to form something that works and can grow, there has to be the prevalent opinions and the prevalent narrative, the prevalent statements need to be sensible. They need to be, reflective of the reality of the world. In some sense, they need to be scientific, But as these systems grow, it doesn't, and they get their own sort of conventions, and they set up their own infrastructure and their own rules. It doesn't actually need to be the case that those with the biggest voices are the most sensible. They don't need to reflect the realities of the world as much, because the structure is there to basically mitigate and calm the anything that those voices might say. So if some voice comes up and says, "Oh, we should do something really dumb," then the structure is there, the checks and balances, if you like. That's part of the structure, oftentimes, to reduce the potency of that, or to remove the possibility that those leadership voices can do stupid stuff with the system as a whole. And so those voices over time, as the system grows and becomes more stable, those voices can actually be dumber and dumber and dumber because the system can handle it. You know, the system can handle the bigger voices being dumb because it's no longer listening to them as much. They're no longer carrying as much weight as they were when the system was small and the dependence on those voices was much higher. So yeah, I think that's largely what's happening over the time. These voices have got kind of dumber and dumber and more self-interested. And you do, if you look out on Twitter for the big followers, you'll see a lot of noise out there. You'll see a lot of people self-promoting and giving kind of faux academic and faux making all sorts of claims, and a lot of the time it's really nonsensical. It's not. There's no real truth there.
You seem to have gone a different direction. I mean, I guess you could have rested on your laurels, but then you started Grid Singularity, Parity, Web3 Foundation. In a way, I'm using my hands to show like the support, like broadening the support, and hope, I don't know, but it feels like putting some control into the masses' hands. Can you talk about what this 2-year intense period with Ethereum, how you shifted and what your focus is now?
Yeah. I mean, so with all of the things that I do try to stay, you know, reasonably true to this, to the pursuit of academic curiosity and being, you know, honest in your honest and comprehensive in your researching, in your experience. And that's broadly kind of guided what I've done, Ethereum, but also after Ethereum. Yeah, and you're absolutely right. Like following Ethereum, I really could have just you know, sort of retired or whatever. But you know, at the end of the day, with retirement, you've got to ask yourself, well, you know, what do I want to do? If I could do anything, what would I want to do? If I have all the time. And I think I was doing that already before Ethereum. I actually only like was in paid work for a relatively small period of my post-university time. I think of those 6 years, I think I spent at most 2 years in paid work. And the rest of the time I was just doing personal projects. I was, you know, doing bits of research. I was coding up, prototyping bits of things that I was interested in. And that's what I wanted to do. So following Ethereum, well, you know, I'm going to continue doing what I want to do. And at the time, I was still kind of interested in crypto and blockchain and trust-free technology. So I continued doing that. And as it so happens that if you have a company with other like-minded people, then you can do you can be more productive. You know, you can get further in what you're doing. A bit like if you've got a research group. And so I set up this company. Happily, I had a few other people that wanted to come along with me. And the foundation was, again, thankfully, I was in a position where I could set up a foundation and have it be tasked with pushing forward basically what we had initially tried to start in the Ethereum days, this idea of a technology set that would allow you to create applications, unstoppable applications in the mold of Bitcoin, but you know, for arbitrary kinds of business logic rather than just currency. And yeah, Polkadot was sort of one of the building blocks that I figured was going to be a fairly important one to build in trying to realize this goal. So honestly, it's I didn't really need to re-examine my life or anything after Ethereum. It was kind of just more of the same thing. Thankfully, I would add, you know, it's just like my outlook already was able to tell me what to do in the case that I had all this free time and had some resources at my hands to be able to, you know, put effort and put other people's efforts in a particular direction.
That's lovely. What feels successful to you now? What do you want to see happen? What would you, I mean, I know it's a little early to talk about a legacy, but you're doing a lot. What would feel good? And then I'm going to ask you to follow up with the last question, which will be, what would you tell our students? What should they focus on? So
I think so I think you always, when you're doing stuff, obviously, you know, you can get a good buzz from just being productive. So you can get a good buzz from writing software, coding stuff up, and seeing it work. And this is partly what, you know, sort of pushed me in the direction of games. I kind of see games as sort of somewhere between software and art. You know, you kind of, but I think at the end of the day, it's good to have a sort of bigger goal that you want to accomplish. And certainly when you set up a company, these days it's important to have something beyond what it is, beyond making money. You know, of course a business is meant to make money, but if you only have making money as your goal, then you'll basically, you'll forever be a slave to relatively short-term constraints. And it won't give you the longer-term direction. You won't have the if your business starts making money, you won't know what to do. That's what it comes down to. Whereas if you have a longer-term vision, a longer-term goal for how you want to change the world, then what you believe, for example, something that you believe is important, freedom of speech, civil liberties, I don't know, some sort of socialistic thing, ending world hunger, peace, whatever. But if you've got some larger aim, then making money becomes a means to that. And you can rationalize why you're making money and why you need to make money. And this allows you to fit it into a framework of a much longer term structure, much longer term goal structure. And I think this is like super important. And if you judge your longer term goal structure well, then it means that you'll be able to, as someone who is running a business, you'll be able to incentivize people much, much better. People will only work for your money for so long before they go and work for somebody else's money. But if you have a goal that people believe in, a vision for changing the world that they identify with, then you can pay them nothing and they'll still work for you. Yeah. And that's what we're seeing in the crypto space. Yeah. People have started working for Bitcoin, working in Bitcoin, essentially for Bitcoin. People started working for Ethereum without being paid. They work for it because they believe in its goal and its vision. And this is crucial to making a long-lasting business. Not many people work in, well, I would say there are many people who work for Elon Musk, for SpaceX, not because he pays them well, but rather because they believe in his goal of taking mankind to Mars, right? It's all part of selling the end of the job, not just the pay packet at the end of the month.
Would you be willing to share your goal with us, your vision with us?
Yeah, I mean, for me, it's crucial. Like I believe in individual sovereignty. I believe that people, at the end of the day, people should be free to. People should be given the responsibility and the authority over their own decisions. Mm-hmm. So this is a little bit in the kind of vein of libertarianism. I'm not a libertarian. I won't describe myself as a libertarian particularly. I'd say I'm quite moderate in my political beliefs. But I do have a fairly strong belief that people should be given the responsibility, given the authority to make their own minds up about things that largely don't affect other people. And this is something that as the world has gone forward, as technology has connected us all so much more, we see an increasing level of arbitrary responsibility that's been imposed on people. Essentially, it's like, it used to be the case, for just to take speech, freedom of speech as an example. It used to be the case that there was, basically you could say whatever you wanted within your own circle, and it didn't really matter if it offended somebody outside your circle, because they would never be able to hear what it was that you were saying within your circle. With the introduction of the internet and this like super hyper connectivity, then that's no longer the case. You say something sort of that is notionally in your own circle, and that hyperconnectivity will ensure that sooner or later what you have said will find its way to someone that finds it problematic. And if you're a nobody, it doesn't really matter. But the less of a nobody you get, the more of a problem it becomes. And this is this is I don't think it's. I think it's one of the many sort of unexpected alterations to society that the internet has created.
So
and
a question for you, and I didn't mention this earlier, but you're making me think about it. We have a mystery speaker coming after you because it's really hard for anybody to follow you. A gentleman named Eric Schmidt, and he's the former CEO of Google. I'm curious, based on what you were saying, what would you ask Eric if you were in that conversation with him?
When you eventually reach the goal that you're aiming for with the company, do you think that overall society will change for the average individual for the better or the worse? And if for the better, why and what trade-offs do you think you have to make?
I think it is incredibly lovely to end on a question and the pursuit for curiosity. So I just want to thank you for your time for this conversation. It was fascinating and unexpected and educational. And I'd like to turn it over to, I think, the most important people here, the students. I don't know if you all would like to kind of raise your hand, or we're a smaller group. Just throw out a question. We have about 20 minutes. Does that sound all right, Gavin?
Sounds fine.
Who would like to go first?
Can I go first?
Yes.
My question, okay, I'll introduce myself. So my name is Amrita, and I'm a student at UC Berkeley. I'm studying sociology and media studies, and I'm going to be interning in tech and advertising and sales. So I'm like really interested in like the non-tech aspect of tech and startups. So I'm working on some startups right now at school. And my question,
is that you talking? Sorry, I just can't see your screen.
Yeah, I don't have my camera on, but yeah, that's me talking.
Do you mind?
And so I'm not able to right now. My question is, I'm interested in like, there's been some concerns about like the environmental impact of people. Like there are people in my high school, I live in the Bay Area, and people were mining Bitcoin a lot in high school. And like, it was using up a lot of electricity because they had like monitors all over their house. And so I've heard about like the environmental impacts of all this electricity usage. So my question is like, what do you think about that? And like in scenarios where the amount people mining doesn't really justify the electricity costs and the environmental impacts, like how do we reconcile with that?
Yeah, I think it's a really terrible waste of energy. In fact, so there's a couple of consensus, two or three, you might say, sort of big consensus classes for blockchain. So this is how all the different nodes on the network determine which order of the transactions have happened, and indeed which ones are considered to be final, considered to have happened. So as I say, there are sort of three or ish kind of big variants of this concept, three big means of finding consensus. One of them is proof of work. This is the one that Bitcoin uses and Ethereum uses. POW, proof of work. And yeah, you're absolutely right. Proof of work basically burns through power, burns through computation in order to find a solution that satisfies some particularly difficult problem. In order to prove that you've done so much work, you should be allowed to finalize or whatever, validate some transactions. Now, this isn't what modern crypto systems use. This isn't the consensus mechanism that modern crypto systems use. Modern crypto systems tend to use one of the other ones. The other one's a proof of authority. This is a term that I came up with back in like 2014, 2015, and essentially means there's a bunch of predetermined authorities and they get to decide which transactions have gone through or not. They can author the new blocks. And then proof of stake, which implies there's already a crypto economic system, there's already a token distribution, they have some tokens, you have some stake, and it's the stakeholders, usually by pro rata with the amount of stake that they hold, that are the ones that get to produce the new blocks, the ones that get to finalize the transactions. Now, these don't use energy. These I mean, they run on computers, but they don't waste, they don't burn through energy like proof of work. I don't actually call it proof of work anymore. I call it proof of waste. That's a more legitimate term for POW, proof of waste, because you're not proving that you're doing any work really. You're proving that you are wasting energy in order to solve this pointless problem. And it's through the demonstration that you have wasted enough energy to solve such a pointless problem that you get to be able to mine a block and get some Bitcoin for it. So I don't think it's a good idea. I mean, I think it's sort of the fossil fuels of consensus mechanisms. It's something that we need to replace with the green energy of consensus, the sort of wind power of consensus mechanisms like proof of stake. But yeah, it's unfortunate that Bitcoin is using it and that it will probably continue using it indefinitely. And I completely hear the complaints, and I think they're valid. And it's not something that I agree with, that I would back. Let's say I don't back Bitcoin's continued use of proof of work.
That makes sense. Thanks.
Hi, Gavin. I'm James.
Hey.
I'm a sophomore here at Berkeley studying EECS, and I just really appreciate you coming out. It's been really great. I guess my question is like gas fees, like right now on like Ethereum are like really going up, and like I guess like a major issue like scalability. And I think that's like one of the things that like you decided like split apart with Ethereum because like Polkadot and like your view of like how Ethereum should be like evolving. So I guess like I'm not sure exactly what your opinions are about that, and I kind of wanted to see like what your thoughts were.
Yeah, it was pretty clear that Ethereum wasn't going to scale super well, even when we were coding it back in like 2014. It was more of a proof of concept, more of an experiment. I did it because I was curious. I did it like for the reason I do most things. I was curious, and I wanted to know if it could work at all. But yeah, we calculated roughly how many transactions it could process. We knew that it was programmable to a point, that you wouldn't be able to do really difficult stuff on it. I remember like back in March, Augur, who were they were just starting out, the prediction market team, and they were doing some like complex matrix arithmetic to figure out like the prediction market stuff, and they were trying to do it on chain, and it was like, yeah, we can't fit this calculation into a block. It's so complex. And we were like, well, yeah, you can't do like actual work on the chain. You can do like bits of record keeping and little bits of like business logic and financial arithmetic, but you're not going to be able to do serious calculations on it. And of course, yeah, Ethereum 2 was always sort of planned that was going to solve this, but it became clear to me that after having sort of left the Ethereum Foundation, gone into Parity, and started implementing the Ethereum client in Rust, and we were working with the Ethereum research team for a while. It became clear that this wasn't going to happen very quickly, and we had a pretty good idea about how to make what we thought was an interesting and scalable system happen. And that became Polkadot. And yeah, we basically went off and we decided to code it ourselves. So I think that Ethereum 2 will eventually be released. I think that it will eventually have a degree of scalability. I don't know if it will scale quite to the degree that people want, and I certainly don't know if it will scale to beyond what other similarly decentralized systems will be able to support. But you know, I don't think scalability is the only thing that needs solving, whether by Ethereum or anything else. I think it's an important hurdle to jump, but I think that there's a few other things, interoperability. I think that developability, and one of the really crucial things that I actually wrote about this stuff in 2016 in the yellow paper, the original yellow paper. Sorry, the original Polkadot paper, was that the ability for a digital system, especially one that's based on the internet these days, to seamlessly upgrade itself is really crucial. Like software these days, you know, you have your apps on your iPhone, you have your sort of web-based applications. These things will update themselves all the time. Like you can't stop them updating themselves, right? Most of the time. It's a different mechanism to the old kind of 90s era where you download the sort of new version of the software and install it. Everything is presumed to be up to date all the time. And if you don't allow for constant fluid upgrades, then you're going to be on the back foot. You're going to be left in the dust for the systems that basically do allow for it. So this was one of the crucial things that I built into Polkadot, beyond sort of the scalability aspect, this inherent upgradability. Now, I was asked by somebody, as it happens, back in 2014, a guy in Stanford. We did a very early Bitcoin Ethereum meetup in Stanford, like February, I think, March, something like that. And a guy said, what do you do when you want to upgrade Ethereum? And we didn't really have an answer. We were like, well, you know, people will just run an upgraded version of the client. And it was like, well, but then everyone, the whole network around the world, the decentralized network, will have to all upgrade at the same time. We sort of talked about version markers and voting and stuff, but basically we didn't have an answer. We didn't have an answer for it because there isn't an obvious answer for how you upgrade a decentralized network. It's not like when you're Google and you just release a new version of your website. And this is also something that I did a lot of thinking between 2014 and 2016 on. And I came up with, you know, some basic governance mechanisms. And I came up with this notion of a WebAssembly based meta protocol. So basically you put all your business logic in WebAssembly, and the only thing about the protocol is that it knows how to execute WebAssembly. So you can essentially upgrade all the bits of your protocol whenever you want. That would have answered this guy's question super well, but we didn't think about actually sorting this stuff out back at the time. Now, the problem with Ethereum and most other networks is that they haven't thought about this stuff yet. They're like, no, we're just going to solve the problem right now and in one fell swoop, and anything else we'll handle with like hard forks or whatever. And the problem with hard forks is that they're really, really difficult to execute properly. You know, you can't do them often. You can't do them, and when you do them, there's a huge amount of risk. I think Ethereum's last hard fork, I think Constantinople was it? It didn't go through at the last minute. It was stopped at the last minute because there was like a consensus error with one of the implementations. And they want to continue this with these two, and that's going to be even more problematic because there's so many more validators, and you've got all of the additional kind of sharding stuff happening. Terrible. So no, scalability is important, and it's something that I really did try to push forward with, but also upgradability and the governance mechanisms that back the upgradability are also extremely important.
Cool, thank you so much.
That's great. This is fascinating, and a whole new language. Ravi, I think we have 3 more questions. Hopefully we have time. Ravi, and then Alice, and then Nate's going to ask the last question.
Awesome.
Ravi?
Cool. My name's Ravi. I'm a EECS freshman, and it's super cool that you're here. So given what you said on individual sovereignty, I'm just curious what your thoughts are on the future of tokenized equity.
Bright, I would say, in a word. I think tokenization has a lot of great advantages. I talk to VCs; they're like super keen on tokens over traditional equity. The liquidity is so important. The fact that investors can come and go as they deem the team and the product to be better or worse over time. And it really does allow for the market, the sort of the heart of the capitalist machine, for the market to have an effective role in the progress of early stage businesses. So I think tokenized equity is a super great invention. I don't think it's there yet as a product. So tokenized equity, has two big hurdles. First is legal hurdles. It's like, security tokens are problematic. As soon as you tokenize something, it will typically become tradable by public. That's a problem, particularly in the US. So this has to be worked out first. Second problem is kind of transparency, and what the regulations actually are, the sort of typical securities regulations are actually there for, which is essentially providing the right amount of information, the right sort of education for potential investors to be able to judge their investment correctly before going in. And we need a lot better infrastructure that can be done in crypto, of course. It can all be done on chain. It can all be done very efficiently and in a very agile fashion. But we do need that those judgments, that reputation, that information, all of the stuff that all the information that you need to that you would sort of put together in order to make a good decision, a reasonable decision on whether a team is actually worth investing in or not. And that needs to move forward quite a lot before I think the regulators are going to be happy to sign off on this thing, actually, basically securities tokens being acceptable to be traded by members of the public. But of course, you can then have a more permission system and only let accredited investors come in, and that I think reduces the utility of tokenized equity. I think it's still useful. It's still a good thing to have. It's still a useful invention. But I think a more useful thing is to democratize investment so that an investor or someone that has the intellectual and intellectual capacity, even if not the financial capacity, to make a large investment, to make a significant investment, is still not hampered by regulators that essentially don't let them do that until they can IPO. That's its main sort of advantage that I think a lot of crypto, via the sort of ICO mechanism brings. I think that is still an advantage, but I do think that there does need to be this additional infrastructure to ensure that the right amount of education and information is in place, and that cannot be gamed or corrupted or biased against the interests of the smaller investors.
That's great. I'm going to ask Alice to come on. Obviously, you've given Ravi a lot to think about, thinking there. Alice, you want to come on and ask your question?
Yeah, sure. Hi, I'm Alice. I'm a freshman studying computer science. And my question is, as we see cryptocurrency being further integrated into commerce and society, we're also seeing the development of quantum computing that can potentially threaten the blockchain. So where do you see the future of cryptocurrency development to combat this?
Yeah, I mean, there are some next gen cryptos. ETH2 is one that I know that are already taking steps to mitigate the effect of quantum by using, you know, post-quantum crypto. I think it's sensible. I think it's a good precaution to take. It's not something that we've done so far with Polkadot, but the thing is with Polkadot, we don't really have to do it because most of our crypto is already in the business logic that we can upgrade at more or less any time. So we already have, for example, for transaction signing, one of the sort of key parts of the crypto, one of the key sort of use cases of the crypto is we already have like 3 mechanisms for signing transactions. We could add a 4th; it wouldn't be a big deal, and the 4th could be a post-quantum crypto. So I think you need to either bake post-quantum crypto into your protocol, like ETH2 are doing, or you need to have a coherent upgrade strategy that doesn't involve, you know, basically writing a whole new network and just sort of moving people over piecemeal like ETH are doing from ETH1 to ETH2. I mean, beyond the sort of negative aspects of quantum, like the ability to crack our existing financial system, the positive aspects, I haven't like given a huge amount of thought to, but like I'm sure there are some really interesting uses for you know, quantum tunneling and sort of the you know, incredible sort of potential communications advantages that we could get. Yeah, I think those will become clear over the next few years as we get closer to real world use cases, sort of being able to actually use them in real world products. Because I think they only sort of did the first little bit of quantum tunneling in the last year or two. So yeah, we'll see.
Thanks, Alice. Our last question is Nate, but I'm going to fit something in before that, just a little selfishly. It is pretty inspirational to listen to you, and I'd like to not be starstruck, but I just am a wee bit. So I'm wondering for also all of our students, if we want to come and get on your team, if we want to work with you, how would we do that?
My email is gavin@parity.io. So just fire one off, and yeah, we can have a talk.
Interesting. Nate, Paulo, I'll let you take it away. Close us off.
Hi. Okay, hi. Well, thanks, Gavin, for everything you've talked about so far. So anyway, I'm just wondering, so in a TED Talk in Vienna a few years back, you quoted Buckminster Fuller saying that to change something, build a new model that makes the existing model obsolete. And so I was wondering, does Polkadot do this now? And if so, how? And then going off of that, like, what do you think is the biggest hurdle for like Polkadot to overcome to accomplish its goal of giving control of the web to its users?
Oh, well, okay. Good question. Right. Well, when I mentioned yes, Mr. Fuller, Dr. Fuller, maybe? He was yeah. I was sort of more referring, less referring to Polkadot, more referring to trust-free technology as a whole. So you know, sort of crypto ecosystem as a whole. But insofar as it relates to Polkadot, I would say a little bit. If we talk about smart contracts, it's a bit of a paradigm. You know, it's like this idea of a metered scripted execution. Metered means of executing logic based upon you know, generally a single account that holds some funds. So you've got a very particular kind of model. You've got an account holding funds. You got some code attached to it. You ping the account. The code runs. It meters it. It deducts some funds from either the sender or the account in order to pay for that computation. Now, when I came up with you know, Polkadot, I kind of ditched that model. I found it was far too constrained, and rather went for this parachain model. The parachain is a completely different, a much simpler computation model. Computation model is this. You have a validation function. So this is a very, very simple function. It takes a existing state and some data, Now the state is generally going to be characterized in something small because we're cryptographers, we can hash everything. So it's maybe like, 32 bytes, or maybe we put in a bit more, but not too much. And then you have some data, maybe a bunch of transactions, and some witness data, and you turn it into a new state, or like a kind of, no, this is no good. And this is a very, very trivial almost function. It's just an automaton, right? It's a very, very simple state progressing automaton. And we disregard all the gas stuff, and we disregard user accounts, and we disregard even the notion of currency. That doesn't matter for the purpose of this validation function. And then we simply encode the validation function in WebAssembly, and we say, right, well, look, if you can find a validator that is on Polkadot that can actually, or a bunch of validators that will actually execute this function on your existing chain state and give you a new state, one that declares is valid, then fine, we'll update the state, and that's it. Very simple. And this allows you then to have to offload all of your opinionation, right? As we say these days in software engineering, all of the sort of design decisions that you have made as to, what's your account model? What does your currency look like? Should the code be attached to currency? Is there just one piece of code? How does your code look like? What's the language that the code's written in? All this stuff, all this opinionated design stuff, you've offloaded that outside of your core into, like, some other part, the shard, right? In this case, the parachain, the shard. And that means that you can let people experiment with it. You can have lots of different versions of this, lots of different design decisions, all happening at the same time, all with their own market attached, all allowing their users to choose between them and let the ones that are good win out, and the ones that are not so good lose, go to the bottom, and get swept away by other experiments. And this is crucial. This allows evolution. This allows your overall system to find its its optimum. And you can't really, if you bake in the more opinionation and design decisions you bake in to your core unchanging piece of your architecture, then the more stagnation you'll get, right? The less you will be able to kind of crowdsource your design, and that's really bad. So Bitcoin did it basically. It didn't crowdsource any design. Ethereum crowdsources a bit of its design because it's got this smart contract paradigm, and Polkadot throws out the smart contract paradigm and creates something which I would kind of hope, in the sort of words of Buckminster Fuller, is makes it irrelevant for under this new sort of model. Remind me of the second part of your question.
Oh yeah, I was just asking in general about, like, what do you think is the biggest hurdle for Polkadot to overcome in accomplishing the goal of giving control of the web to its users?
Yeah, I think the biggest thing to overcome is actually going the last mile in decentralization. If you want to, like, we talk about unstoppable applications on Ethereum, but they're only unstoppable to a point. Most Ethereum applications make use of centralized websites. They make use of centralized pieces of technology, such as the MetaMask browser extension or Etherscan.io or whatever. This is really problematic. It basically means that anyone is able to shut down any application on Ethereum if they want to enough. So while the underlying business logic might be able to progress, the user experience will halt. And so what we actually need for Polkadot, and indeed any other system that wants to build unstoppable applications, truly decentralized applications, is a means of ensuring that the user experience cannot be halted, just as the core business logic cannot be halted. And ultimately what it means is that we need in-browser light clients, and we need a way of bootstrapping those light clients into the network, so they can quickly sync, but they can quickly find nodes to sync from in a secure fashion. Now, when you use BitTorrent, right, we had, you remember the old days of BitTorrent, you had BitTorrent trackers. Now these would be basically web servers that would track the nodes, the peers of for a particular, that were sharing particular data. Now, eventually these trackers got themselves tracked down and shut down as it was discovered that they were sharing information that was for data that was copyrighted or whatever. And so in place of the trackers, there became magnet links. Now, magnet links are essentially cryptographic hashes that describe the data that should be downloaded, but there is no operator behind them. In fact, there's just a global DHT that itself is run by nodes, but the nodes don't track any one particular piece of data. They're just DHT nodes, and thus it's not really, you can't really shut down a whole global DHT network. It'd be like trying to shut down Bitcoin or whatever. It's just too many people running too many nodes, doing too much random stuff that's actually useful and isn't hurting anyone. And so these magnet links now offer a lookup into this global DHT, and the global DHT is able to then give you information on which the tracker would otherwise have given you, and that makes it impervious to censorship, impervious to the various other liberty restricting currents in modern life. And I think one of the key challenges with Polkadot, indeed other crypto systems or the sort of unstoppable application platforms, is to bring this kind of an outlook, this kind of an architecture into the blockchain space, and allow essentially someone to fire up a browser, fire up a website which in and of itself is just code, is just a hash. All that you should ideally need is a hash, a string, an idea, or even better, an identity, like a URL, like a domain name. And this should then, through decentralized technology only, and through stuff that works on global opaque data transfer networks that are impervious to a minority sort of attack, should be able to get you to the point of being able to use that application. And that's like, that's still a while away. That's still not done. But when that can be done, then we will be, I think, at the point where I'll be happy to take a step back and sort of call this a job done.
Thank you.
Thank you for a fun and fascinating morning. I have no doubt that that you will call that a job, and you'll continue. It'll be fun to watch the journey. I appreciate the time with us, and thank you also for parity and partnership with the Blockchain at Berkeley group. It's a pleasure to have you, and if you'd like to come and join us for Eric Schmidt, you are welcome to.
Well, thank you for having me. Thank you for the invitation. Very kind. And yeah, it was lovely to talk. Always nice to share and discuss.